Okay, have you ever really looked at a mirror and wondered how it's made? I mean, it seems like pure magic, right? Taking a totally clear piece of glass and turning it into this perfect reflective surface. Well, today, we're going to pull back the curtain on one of the most beautiful reactions in all of chemistry to see exactly how science creates that shine. It sounds like a riddle, doesn't it? How in the world do you make a mirror using something as simple as sugar? It feels like it shouldn't be possible, but that's exactly what we're going to break down. The secret is in a classic chemical process that is just as elegant as it is impressive. And here it is, the silver mirror reaction. At its core, it's a process where we basically convince silver, which is just floating around dissolved in a liquid, to come out of that solution and coat a piece of glass in this super thin, perfectly smooth layer. So no, it's not magic, but honestly, it's the next best thing, just pure chemistry. Now, to pull this whole thing off, we need a very specific cast of chemical characters. And trust me, every single one of them has a critical role to play in this transformation from a clear liquid to a shiny, solid mirror. So here they are, our four key players. First, we have silver nitrate. That's obviously where we get our silver from. Then we have ammonia and sodium hydroxide, which help get that silver ready for the reaction. And last but not least, dextrose. You might be a little surprised when you find out what that last one actually is.
That's right. Dextrose is just a simple sugar. But in this reaction, it is the absolute hero. It acts as what chemists call a reducing agent. A simple way to think about it is that the sugar is the power source. It provides the chemical push, that little bit of energy needed to force those dissolved silver particles to become a solid metal mirror. Okay, so before we can get our mirror, we have to mix up a very special chemical cocktail. This is not something you can just buy off a shelf. You've got to prepare it very carefully right before you use it. This solution is the absolute key to the entire process. This special mix is called Tollens reagent. It's what you get when you precisely combine our first three ingredients, the silver nitrate, ammonia, and sodium hydroxide. Inside this solution, the silver is held in this unique chemical state, just perfectly primed and ready for that final step. And you know, it has a pretty cool history too. This brilliant little test was developed by a German chemist, Bernhard Tollens, way back in the 1800s. And it was, and still is, an incredibly useful tool in a chemistry lab. All right, we have our Tollens reagent and we have our sugar. Now it is time for the main event. Let's dig into the chemistry that actually creates that beautiful shine. The magic is all in a type of reaction called a redox reaction. Now, that might sound a little complicated, but you can really just think of it as a kind of chemical dance. In this dance, one partner, our sugar, the dextrose, gives away some electrons, and the other partner, the silver, very happily accepts them. This table here just breaks down that dance perfectly. So on the left, you've got dextrose. Its job is to donate electrons, a process we call oxidation. And after it gives them away, it actually transforms into something new called gluconic acid. Now, look at the other partner. The silver ions accept those electrons. We call that reduction. And by doing that, they transform from being invisible ions in a solution into pure, solid, metallic silver. That's it. This electron exchange is the entire secret. And this is the whole chemical story written out. Now, don't worry about memorizing it all, but just look at what's produced on the right side of that arrow. The most important part is right there, 2Ag. Ag is the chemical symbol for silver. That is our solid mirror, appearing right out of a liquid. It's incredible. Okay, so let's see how this actually gets used in the real world. This reaction is way more than just a cool party trick. It has some really important applications. But, with great chemical power comes great responsibility. So why does any of this matter? Well, remember our hero, the dextrose? It belongs to a family of molecules called aldehydes. The Tollens test is the classic go-to way chemists check for them. If you add the reagent to some unknown solution and a silver mirror forms, bam, you found an aldehyde. And, on a more festive note, this is the very same process used to create those beautiful silvered glass ornaments you see during the holidays. Now, before we go any further, I have to stop and stress something that is extremely, extremely important. This is a reaction that demands respect and absolutely proper safety procedures. And this right here is a non-negotiable rule in any lab, anywhere. You must prepare Tollens reagent fresh right before you use it, and you have to dispose of it properly right after. If you let this stuff sit around, it can form an incredibly unstable and dangerously explosive compound called silver nitride. Seriously, safety is always number one. So let's bring it all back home. The crucial point, the main takeaway is this. We've taken what seems like a mystery and explained it with science. That beautiful, shimmering mirror is created simply because a common sugar gives away its electrons, providing the energy to turn dissolved silver ions into a solid, reflective metal. It's just a perfect example of the hidden power that's locked away inside molecules. And that brings us to the end. It really makes you wonder, doesn't it? If a simple sugar can do this, what other kinds of magic are just waiting to be uncovered in a chemistry lab, all governed by the elegant rules of science? Thanks for tuning into this explainer.